Okay, good afternoon. So for continuation for our topic, applications of differential calculus. So dito tayo ngayon. So na-discuss na natin yung rectilinear motion or free fall. So mostly nag-focus tayo sa free fall, di ba? Then ayun nga. So proceed tayo ngayon. Fuck. Sorry. Nag-proceed tayo ngayon sa another way to use another way na pwede nating paggamitan ng ano natin, ng relay ano natin. Tawag calculus. Okay? So technically wala siyang ibang way to tackle this one, but of course by using technically sample problems. Okay, so technically when it comes to differential calculus, palagi, okay? Guys, once there's a given equation, okay? So let's say we have an equation na f of x, okay? So let's say we have yun nga, f of x. So certain equation f of x, ano mga equation yan? Technically, once you derive it, okay, once na nagpumunta ka sa first order derivative, ang tawag palagi, okay, ang tawag dyan is rate of change. Okay? Palagi yan. Yan ay pagbabago. Let's say we have a certain equation. Okay? Kuwari equation ng volume. So volume ng sphere. So f of x equals to 4 pi r cube. Okay? Kuwari ganyan yung working equation natin. Once na dinerive natin yan, guys, diba? Which is equal to 4 pi r squared. Technically, yan na rin yung change. Yan na yung rate of change ng volume natin. Okay? Yan na yung rate of change ng volume natin. Volume. Okay. Rate of change of volume always with respect to time. Okay? Pero mostly, di naman pinapansin time. Pero yun nga. Okay? Rate of change of volume. So, ito, we can now say na dv is equals to 4 pi r squared multiplied by change in radius. Okay? So of course, di ba? Meron tayong dr din dyan. Okay? So, ayan. Tatandaan nyo palagi. Always, yung first natin, sa related rates lalo na pagdating sa related rates, ayan nga. Always, first natin is always ganito. Okay? So, ayan. So, start tayo. Okay, pwede na tayo mag-start. So, start tayo for first problem natin. Okay, sample problem number 1. So, another sample problems yan. Ay, mali yata na share. Ito pala sa... Okay, so ayan. So solve natin tong first problem. So dito, the cost C in dollars per day of producing X TV sets per day is given by the formula of, ayan, okay? So C is equals to 7,000 plus 50x minus 0.05x squared. Okay, so find the rate of change with respect to X when 200 sets are being produced each day. So technically, so may, as always, pagdating naman sa ganito, may given formula na siya. Okay? Most of them. So yun nga. So yung cost daw natin per day is may ganito siyang formula. Okay, 7,000 plus 50x minus 0.05x squared. Okay? So yan na yung rate of change. Yan na yung cost mo every day. So once na dinerive natin siya, guys, kung naging C prime siya, magiging 50 minus 0.x, tama, di ba? 0.x, yan na. Yan na yung rate of change nung cost mo with respect to x. And then dahil may binigay doon na ano ngayon yung magiging cost mo. So, ayan. Find the rate of change with respect to x when 200 sets are being produced each day. So, technically, substitute lang natin yung value ng x. Di ba? So, 50 minus 0.1 200. Okay. So C is equals to 50 minus 20. So rate of change mo is around $30. Okay. So yan yung ano ba to? Naka per dollar ba to? Oh, naka per dollar nga. Ayan. So, ayan. So, yan yung rate of change mo once na nagpo-produce ka ng 200 radios per day. Di ba? Ganun lang siya kadali. Okay? So, next tayo. Okay? So, ayan. Next tayo, guys. Problem number 2. Okay. So, problem number 2, ito. Okay. So, the volume V of a sphere of a radius the volume V of a sphere of radius r is given by the formula. So, yun nga, di ba? Constant naman yung formula ng sphere, which is 4 pi r cubed over 3. How fast is the volume changing relative to the radius when the radius is 10 millimeters? And what is the change in volume when the radius change from 10 to 10.1 millimeters? Okay? So, ayan. So, ayan yung working problem natin, and let's try to solve this one. Okay, so ayan. First, we have the volume. Okay. So, volume is equals to 4 pi r cubed over 3. Okay, and then, sabi, gaano siya kabilis nag-change relative to radius? Okay, when radius is 10 millimeters. So, change in volume is equal, okay, change in volume is equal to, so ayan, is equal to, ayan yung working equation natin. So, magiging, as what I said, V prime is equals to 4 pi r squared. Diba? So, dV is equals to, so may r tayo na 10 millimeters. Okay? So, substitute lang natin yan dyan. So, 4 pi multiplied by 10 squared. Diba? So, dV is equals to 400 pi millimeter squared. So, ganyan. So ganyan yung rate of change natin once na yung radius natin is 10 millimeters na. Okay, yan yung ganyan kalaki yung changes ng volume. Okay? So, yan yung sa first problem natin. And then B. So, technically sa B, medyo tricky siya kasi sabi, what is the change in volume when the radius change from 10 to 10.1 millimeters? Technically, ano lang naman to? Ano lang yan, parang kukunin mo lang yung volume both, ano. So, ayun lang. Technically. Okay? So, kunin natin yung volume both sides. Okay. Teka. Kukunin mo lang yung volume mo sa una, sa 10 mm, tsaka sa 10.1. So, ayun lang. Technically. Okay? So, kunin natin. 4/3 pi r cubed. So, 10 cubed minus, or baliktad. Teka, sorry. Ba't binuro lahat? Pwede pala. Okay, so ganoon lang siya. So, 4 cubed pi 10.1 cubed minus 4/3 pi. Okay, gets. So, technically, ganito siya. Okay? So, first, we have change in radius. Diba? Balik tayo sa formula. So, ayun yan. So, actually, may ano pa yan, dr. Ganyan. Pero dahil wala naman siyang value. Okay? So, ganito siya. Wait lang. Okay, ganyan. Tama. Ganyan pa rin pala. Okay, so ayan, with respect to radius. Okay, so ngayon, sa next problem natin, sabi, ay yung sa sunod, what is the change in volume when the radius changes from 10 to 10.1 millimeters? So technically, meron tayong change in radius na 0.1. So yun yung magiging ano natin. So from here, actually, yun, i-equate lang din natin siya. So change in volume is equals to 400 pi millimeter squared multiplied by 0.1. Yun lang. And then, ayan na, final answer is equal to 40 pi millimeter squared or millimeter cube pala. Millimeter cube na siya. Kasi may millimeter ka pa dito. Okay? So, ayun. Technically, yan lang yung change in. So, yung change in volume mo from 10 to 10.1 is equal to, ayan. Okay? While this one, when the radius is 10 millimeters. So, ayun. So, ayan. Bali itong 400 pi something. Ayan na rin naman na yan. Okay? So, ayan yung sa number 2 natin. Hindi siya naka-record. Naka-record pala. Very good. So, next tayo. Problem number 3. Okay. So, next, the length of a rectangle of a constant area. So, may constant area tayo na 800 square millimeters. And yung length ng rectangle natin is nag-i-increase siya at a rate of 4 millimeters per second. So, what is the width of the rectangle at the moment? The width is decreasing at the rate of 0.5 millimeters per second. So, ano muna natin yan? Note natin. First, we have a constant area na LW, which is A is equal to, ano to? 800 millimeters squared. Meron tayong change in L. Okay, change in L. Change in L na positive siya, di ba? So, 4 mm per second. Or, ayan. So, change in width natin is negative 0.5. Okay? Mm per second. So, ayan. So, next tayo. Wait. So, ayan yung working equation natin, di ba? So, first, equate muna natin yung ano natin, yung formula ng area natin, which is magiging 800 is equals to length times width. So, dahil ganyan yung working equation natin, need natin siyang i-derive. So, first order of derivative tayo, guys. Okay? So, magiging, ano mangyayari sa kanya? So, magiging ano siya, di ba? Let's say, ito na yung magiging ano natin, U, ito yung magiging V. So, magiging, ano siya? So, 0 to, dLV. So, L dW plus W dL. Di ba? So, yan na yung working equation natin. Okay? Next. So, mapapansin niyo sa working equation natin, guys. So, ganyan na siya. So, magiging 0 is equal to 0.5L negative plus 4W. Okay? Diba? Magiging ganyan siya. So, ganyan. Okay? Sorry. So, medyo nalilit. Ano lang. So, ganyan na yung working equation natin. And technically, so, naka-first order derivative na to. Okay? So, dinerive na natin siya. So, next natin, guys. So, ang hinahanap dun sa problem natin, what is the width? Ano yung width ng rectangle natin? The moment na nagdi-decrease yung width natin, 0.5 mm per second. Okay? So, magiging 4W is equals to 0.5L. Okay? So, technically, width is equal to, kung equate natin siya dito, guys, diba? Equate natin siya, 0.5. So, 0.5 L over 4. So, width is equal to 0.5 divided by 4, 1 over 8, di ba? 1 over 8 L. Okay? And technically, may value naman tayo ng L. Okay, may value tayo ng L with respect here. Di ba? So, dito tayo. From here muna. Di ba? Meron tayong 800 is equals to L, length times width. Diba? So from here, we can now equate that L is, kailangan kasi natin one variable na lang from here. Kasi wala tayong definite value ng width eh. And dahil binigyan tayo ng value ng area, we can now solve for L, which is, ayan. Diba? Length is equals to 800 over width. So width is equals to 1/8 multiplied by 800 over W. which is magiging W squared is equals to 100. Okay, so square root lang natin yan. Width is equals to 10 millimeters. Diba? So, ayan. Okay, so sabi, so yun yung magiging width ng rectangle natin the moment na nagdi-decrease yung ano natin. So technically, we can get also the value of length from here, di ba? So length is equals now to that moment also, length is equal, so equate lang natin dito, 10 over 8 or equals to, ilan? Tama ba? Mali pala, baliktad. W is equals to L over 8, di ba? So W, so 8 times W is equals to L. So L is equals to ilan? 8 millimeters. 80 pala, sorry. So ayan, 80 millimeters. Okay, kasi nag-i-increase siya. Okay? So ayan yung working equation natin. So ayan. So next tayo. So next. So actually, width lang naman yung kinukuha. Hindi man hinahanap yung ano. So next problem tayo. Ayan. So dito tayo. So ayan. Bali yun nga. Technically, so sa related rates or rate of change, mostly, ganoon na naman yung mga working problems na lumalabas. Okay? So, ayan. So, next tayo. An oil from a cup. So, kaya natin konti. Oil from a cup well in the ocean is radiating. It's radiating outward in the form of a circular film on the surface of the water. So, yung radius ng circle natin is increasing at the rate of 2 meters per minute. How fast is the area of the oil film growing when the radius is 100 meters? Okay? So, solve natin siya. So, sabi sa number 4, may change yung radius natin at every minute na. So, dr is equals to 2 meters per minute. Okay? And then, next, may radius tayo na 100 meters. Okay? So ngayon, ang hinahanap is anong value ng change in area natin once na yung radius natin is at 100 meters. So first, formula muna tayo ng area. Area is equals to pi r squared. Siyempre, formula natin is with respect to r. Okay, so pi r squared. Okay? So next tayo. So next is ano natin siya. So para pumunta tayo dito, so change in area is equals to, ano lang natin siya, di ba? Tawag doon? I-derive lang natin. So magiging 2 pi r multiplied by dr. Okay, matik yan. So next, from here, magiging, so next, may value tayo ng r. So sabi, ang tinatanong, ano yung change in area natin? How fast is the area of the film growing? So gano'n nakalaki yung area natin once na yung radius natin is around 100 meters na. Okay? Di ba? So, change in area is equals to 2 pi multiplied by 100 multiplied by rate of change natin na 2 meters per minute. Okay? So, change in area is equals to, equate lang natin yan guys. So, magiging 400 pi. 400 pi yan. Okay. Pi meter per minute squared. Okay? Kaya na yung ano natin. Change in area natin. Okay? So, yun lang naman yung nahanap doon. So, ayan. Next tayo. So, last problem for related rates tayo, guys. So, sana nagagets nyo pa siya. Okay? So, next tayo. A balloon is being inflated by pump air at the rate. Hindi pa lang nakikita. Sorry. So, ayan. So, may balloon daw tayo. So, a balloon is being inflated by pump air at the rate of 2 cubic inches per second. So, nagbabago yung volume niya at 2 cubic inches per second. Okay? How fast is the diameter of the volume increasing when the radius is 1/2 inch? So hinahanap ngayon yung change in radius. Okay? With respect to diameter naman. Okay? So syempre, ayan, equate natin. So pakita natin kung paano. So first, we have change in volume equals to 2 cubic inches per second. Next, we have a radius na 1/2. So first, doon ulit tayo sa formula. Okay, V is equals to 4 pi r cube over 3. Next natin guys is dV, di ba? dV is equals to, ayan, 4 pi r cube. So, ano natin magiging 4 pi r squared dr. Okay? So, ganyan siya. So, next, meron tayong r na 1/2, meron tayong dV na 2 inch cube pala. Sorry. So, ayan. So, 2 inch cube multiplied by 4 pi r 1/2 squared multiplied by dr. Okay? Or technically, we can solve this in terms of diameter, pero solve na natin in terms of radius na lang. Kasi madali na lang din naman na siya i-convert into diameter. Diba? Kasi ito times 2 mo lang naman siya or divide 2. Diba? Okay? So, ayun. So, ayan. Please close your camera. Sino man yan. Okay. Anyway, so ayan. Yan na siya. So solve natin to para makuha natin yung dr. Okay? So dr is equals to 4 pi 1/2 cube over 4 pi 1/2 squared pala. So technically magiging pi na kasi to. So 2 over pi, di ba? Kasi ito magiging 1/4. So 4 pi times 1/4, pi na lang matitira, is equal to dr. Okay? So ayan na. May dr na tayo. And technically, of course, di ba? Kung ano yung relationship ng diameter natin to radius, ganun din yung relationship dito. So magiging, change in D is equals to 2 change in R. Di ba? So change in D is equals to 2 multiplied by 2 over pi. Change in D is equals to 4 over pi with respect. So 4 inches per second naman. Okay? So, ayun lang yung sa related rates natin or rate of change. So, break muna tayo for 10 or 15 minutes para